Hello, today we're going to work on Chapter 3 Word Problems Day 2 mini lesson. And let me start off by saying you are allowed to use your calculator on all of these problems, but I encourage you to use it as a tool and not replace your brain with a calculator, but just use it as a tool that will help you. You still have to follow the order of operations, so if you don't know how to follow the order of operations, the calculator is going to be of no use to you. In our first example, Charlotte and Luke are mixing lemonade and 7-Up for their third and second birthday parties. Charlotte mixed 3.4 gallons of lemonade in the same bowl that Luke had poured 2.5 gallons of 7-Up. They carried the bowl to the porch and 15% of the punch spilled out. The punch has a weight of 5.23 pounds per gallon. The expression shown below represents the weight in pounds of the punch remaining in the bowl. Rounded to the nearest thousandth, what is the weight in pounds of the punch in the bowl? So I'm going to do this order of operations. I'm going to start with parentheses, and I'm going to go to the innermost parentheses. So I'm going to go to where the 3.4 and the 2.5 is. So I'm going to rewrite this. And I'm going to add the 3.4 and the 2.5. And if you hear me clicking, it's because I'm using a calculator, just like you should be. And we have 5.9. And then times 5.23. And now we're going to do, still inside the parentheses, 0.85 times the 5.9, which is 5.015 times the 5.23. It helps to rewrite your steps so that you can assess if you made an error very quickly. And it's 2, 2, 8, 4, 5. And my last step here, it says round to the thousands place. So we got to remember our place values. So the tens, hundreds, thousands is the 8. And the 4, when I round this, and I have the 4 is not going to change the 8. So it's going to stay 8. So it's going to be 26.228. And it says pounds. So pounds. Next problem. Abigail is determining the value of the expression below. And so the first thing we're going to do is we're going to evaluate Abigail's expression, and then we're going to see if any of the below expressions are equivalent to Abigail's. Equivalent means equal. There could be 1, 2, 3, or all 4 could be equivalent, but we're going to see. So the very first one that we're going to do is the one which is Abigail's. So we're going to follow the order of operations. We're going to do the 6.8 plus the 3.4 inside the parentheses first. So I'm going to have negative 1/2, and then in parentheses is 10.2. Now if I have a number beside a parentheses, it's multiplication. So I'm going to multiply by negative 1/2, which is the same as multiplying by negative 0.5 if you prefer decimals. So we know that our number we're looking for is negative 5.1. So if any of these, A, B, C, or D, equal negative 5.1, then we're in business. And it says expressions, which means maybe more than one could be correct. Let's look at the first one. We're going to do 4.3 minus 1.75 first, 2.55, and that's going to be in parentheses, because we're in parentheses first, negative, and then 6 divided by 3 is going to be 2. So then I'm going to have negative 2 times 2.55, and that's going to be negative 5.1. So we found a winner. I'm going to circle that in a different color. And I'm not going to forget my decimal there. Okay, let's check B. 12.6 is in the numerator. The denominator is going to be 1 minus a minus 2, which turns into a plus, which is 3. Now we're going to divide 12.6 by 3, and we get 4.2, which is not 5.1, so B does not work. We can eliminate B. It's not equivalent, meaning equal to the negative 5.1. C is pretty straightforward. It's going to be negative 15.8 divided by 4, so 15.8 divided by 4, we're going to get negative 3.95, which doesn't work. That's not equivalent to negative 5.1. And then the last one, the grouping symbol are parentheses. When you have an additional operation in the numerator, you want to do that first. So that is also treated like a grouping symbol when you have a numerator and a denominator having separate operations in them. So 30.6 in the numerator and 6 in the denominator. So then we're going to divide by 6. And we got negative 5.1, which is equivalent, the same, ding, 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 ding. Oh yeah, I was doing that in a different color. Okay, on our second page here, we pick up with example 3. Anne is running in the Steelers 5K. The distance she runs is 3.1 miles long. She runs a portion of the distance at a slow speed to warm up and cool down. Anne runs 2/3 of the distance at a fast speed. Of the slow speed portion, a half is for the warm-up. Estimate the mile or miles that Anne used to cool down. So there's a lot going on in this problem. I want to point out some keywords to you. Estimate means we're going to round. Anywhere you can see to round and it makes sense, that's where I want you to do it. And then also we're going to go step by step through it to figure out each fraction along the way. So 3.1 miles, let's estimate that to 3 miles. So we're estimating the miles to 3 because it's way easier to work with. She runs a portion slow speed to warm up and cool down. So the warm up and the cool down are slow. The rest of the race is going to be fast. She runs 2/3 of the race fast. That means 1/3 of the race was used slow for the warm-up and the cool-down. I just want to write myself a note in case they ask me about it. Oh, they do. Of the slow speed portion, half of it is for the warm-up, which means another half would be for the cool-down. Okay, so let's go back to our fractions. 3 miles. 1/3 of the 3 miles is for the slow portion. That would be 1 mile is going to be run slowly. Half for the warm-up, half for the cool-down. What's half of a mile? Also half of a mile, or 0.5, and so half of a mile was used to cool down. Example 4, Lily is going on a Disney cruise. There are 5 people going on the Disney cruise. Lily's dad pays $64.50 for each ticket to whale watch with Mickey. Lily's dad also bought 4 photos from the whale watching excursion. Lily's dad is charged a total of $406.50 for the tickets and the photos. What is the price of each photo? Write and solve an equation. First thing we want to do is define a variable. What are we ultimately looking for? The price of each photo. So I'm going to call P price of photo. You can use X, you can use any variable you'd like. I chose P, make sure you define it. What's our total? $406.50. Now, he already paid for the whale watching experience, which 5 people went on. $64.50 times 5. This is going to be how much he simply paid for them to go on the whale watching portion, which was $322.50. That he had to pay no matter what happens because that was part of the tickets. We already know that cost. Then he paid for the photos of the event, and there were 4 of them. So 4 times the cost of the photo. Now we're going to solve the equation. We're going to subtract the $322.50 from both sides. And let's see, I get to use my calculator, which is nice. Like I said, you can do that. It just makes things a little bit quicker. So $84 for the 4 photos. Divide by 4. Each photo is going to be $21. Example 5, Carly is picking out bedding for her baby girl's nursery. She wants bedding that is pink and has stripes. Good choice. Out of the 72 bedding sets to choose from, 1/6 of them were pink, and of the bedding sets that were pink, only half of them had stripes. How many total bedding sets does Carly have to pick from that are pink and they have stripes? So starting with the 72, 1/6 of them, of meaning multiply, so 72 times 1/6, that's 12. 12 were pink. That's a good start, but she also wants ones that have stripes. Half of them also had stripes, so 12 times 1/2 would be 6 were pink and had the stripes that they were looking for.